Integral calculus is about finding the area underneath curves. Now, finding the area of shapes that I already know is easy enough: squares, triangles, circles. But curves can be all kinds of shapes, so finding the area is a bit more difficult. Well, one way I can go about doing it is just by making an estimation, and that's what this beginning part is going to be about. It's just about estimating what the area underneath the curve would be. So if I had a curve like this, what I could do is divide it up into equal size rectangles. Each one of these distances is delta x, delta x, delta x. And then what I can do is find the area of each one of these rectangles, because I know what the area of a rectangle is. It's base times height. Or, in this case, it would be delta x times f of x. So what is being done here is I'm dividing this area under the curve into equal parts, delta x, b minus a over n, on the interval ab. So x1 is a plus delta x, x2 is a plus 2 delta x, x3 is a plus 3 delta x. So every single one is just a difference of delta x. And this kind of way of approaching it is going to be useful in the future, where we're going to take sums going to infinity. Now, it's obvious to see that these are not perfect areas, because for this side, I'm underestimating it by these triangles, and this side I'm overestimating it by the same triangle. But what can happen is I can get these rectangles smaller and smaller, like so, and it becomes a more and more accurate picture, the more and more rectangles that are made. And when these rectangles here, there are not even 100 of them, probably only about, 20 or 30 of them. And it's already a much more accurate picture. But if I were to increase this number to 1,000, if I was to increase it to 10 million, it would become a very, very accurate estimation of what that would be. So that's the idea behind finding the area under these type of curves, is to use rectangles and then just to make more and more of them until it becomes a very accurate estimation of what that area is. So this is how I would find the area. I would take f of x1 here or here, multiply it by delta x, and that would give me the area of the first rectangle. And then x2, multiply that by the same delta x. f3, multiply it by delta x. And then for as many as I have for n, I can divide this up into as many pieces as I like. So another way of writing this, or another way of thinking of this, is to take the limit as n goes to infinity, which is the number of rectangles, of f of x times delta x. And n is going to depend on, well, this is just going to depend on how many of those rectangles there are. The more rectangles there are, then the smaller they'll be and the more accurate it will be. This is for, there are three different formulas here. It just depends on how one wants to set up these rectangles. I can do them like this, where they're underestimating. I can do this one where they're overestimating, or I can even find out what the center point is, and this would be called x star. And I can even have them centered instead of having them hit at one corner of the rectangle, they can hit on the center. So these are the three formulas depending on which one I want. For this one, this would be this one right here, because it would start at x1 and then it will do the area. So this formula is for this second one. This formula if I put in x1, I get x0. So I would start here, and if I multiply delta x times x0, then for this one it's going to be 0. So this one is for that. And then this last one, again, is if I felt like determining what this middle point would be. And it wouldn't be that hard. All I would have to do is divide whatever delta x by 2 is, and then come up with a formula for there. But this is the idea of finding what the area underneath a curve is, and this is what integrals are going to lead into. And eventually what we're going to be able to do is not just get estimations, but as we learn about sequences, we can find out what the limit of those sequences are as they go to infinity, and in fact I can get a definitive answer, not just an estimation, for the area underneath particular curves.